So let's continue lecture 11. This is 11b, local properties of covariant derivative. You see, I would like also to remark that the objective, the goal, is to obtain tools such that they will be used when you talk, you derive curvature. You see, that's important here. So, property T, see, Leibniz rule in the second argument. Statement, dx fy, f is a function, a scalar. This is xf, this is directional derivative of f, y, f dxy. I want to prove that. So, derivation. We call that fy, you see, is fyj partial of xj. And that's compute dx fy. You see, you just expand xi, this is partial of f yk, xi plus Christoffel symbol fyj, this partial xi. So this xi partial dxi is a vector x. Now, adjust from there, I can write over here, you see, this is, attention, this is partial f with respect to xi, x times xi that multiplies all this, you see, then this leads to this relation over here. You just copy, you see, from here, you just repeat over here. So that xi that multiplies this, this, and this. So you see here, xi, you see, that multiplies, you see, just you group, okay, these two terms are there. So observe that the vector x, which is a flow, is xi partial xi. This is this case is the directional derivative of f. Is xi partial of f with respect to xi. So dx fy is x partial derivative y plus f dx of y. So that's a mark here, the property 4. You see? Now let's move to the property 4 here. Now, property 4 is a special case of property 2. Property 2 we derived in 11a, you see? So, where in this property 2, I set g is equal 0 and just copy from there. This leads to d fx y is f dx of y. Now, let's move to property 5, okay? Now, it's important here, just so you, that I plug this on property 2, this come up to f dx of y. Just repeat that. That is statement, I just set g is equal 0 on step 2, this leads to f dx y. Property 5, formula in local coordinates at point P, which belongs to a chart, so on the manifold. Derivation, recall that, you see, this by definition, the covariant derivative xi, xj is the Christoffel symbols, okay? Also, this is related to the second derivative, okay? That's important here for you to understand, and I already did this previously. So this is Christoffel symbols. Let's say K is a dummy index, Ij, these are free index. You see, the left hand side free index, the right hand side, the right hand side free index, free indices, and the left hand side also must match, okay, the free index. And yj partial of xj. Now, then I partial here, the covariant derivative here, you see this is yj partial xj, you see, there's derivative with respect to xi. I just set this over here. So this the xi y, you see, by definition of covariant derivative, this is not vector x. This is the basis of the vector x. You see? Attention now. You see? So I just set here, and this I can write. You just copy. That's important. You see? J is dummy. I can substitute j by k. You see? So this is partial xk and partial xk. From this I can write over here partial xk. It's quite easy to see it. But xi partial xi, you see, what I want is not the covariant derivative with respect to partial xi. I want the covariant derivative of, in this case, of this here, I will substitute by capital X. You see, is xy partial of xy. So this is a part what I want. So the covariant derivative, I just plug here. The xsi, you see, attention now. Xi, you see here, it is a function. We already derived, okay, when I want to apply when this is a function f. You see? So this is equal, the xy is the xi partial xi y. Okay? Now, attention now, as I said, there's a function. So then I can plug the f, the function f, in this case, the covariant derivative of partial xi of y. Now I can write this here, okay? There's a function f, okay? Then I multiply this result, okay, by xi, okay? So this leads to what I want, the final relation, the step 5, okay? This is a statement. You see, there's an interrogation mark here. So that I want to show, and this is what I obtained, the formula 5. So these are in this case, the properties of the covariant. I would say standard copy, standard formula, standard formulation, standard properties of the covariant derivative. That's important. And remember that our goal is to apply to the curvature. You see, we define torsion. You see, Riemann curvature, Ricci curvature, scalar curvature. You see, as you see in later videos, okay, later lectures.